Electricity is everywhere. It may seem mysterious, but once you understand the science, the light goes on. This segment is all about exploring the transformer. It gets me all charged up. Press a button and your stereo starts. Press the buzzer and the doorbell rings. Simply put, electricity involves using the energy in moving charges. Voltage describes how much energy is available in each unit of charge. What happens when an electrical device is plugged into an outlet with more voltage than it needs to operate? This cell phone needs 12 volts to charge, but the electrical outlet puts out 120 volts. A special device inside of the charger transforms the 120 volts from the outlet to the 12 volts needed by the charger. And that's why it's called a transformer. Go to the bathroom. I'm serious. We need a couple of empty toilet paper rolls to demonstrate the principles of a transformer. You'll also need 10 meters of wire, about the length of any classroom. This wire is insulated with enamel. Before you connect the coils to a circuit, you need to scrape the enamel from the ends of the wire. Coil the wire around the cardboard tube. Now we need to set up the multimeter to observe voltage. Where do the leads plug into? The black lead goes into the black input, and the red lead goes into the input labeled V for voltage. And the dial is in position to measure millivolts. Attach the multimeter to the wire coil. There's no battery in this circuit, so how can charges be given the energy to move? I'll give you a hint. Like your personality, it's all about magnetism. Watch what happens to the multimeter as a magnet is moved through the coil. The charges are being given energy, and the faster the rod is moved, the higher the readings. If you move the magnet slowly, the readings are lower. Notice, too, that the voltage readings are positive when moving in one direction and negative when moving the opposite direction. The coil produced voltage readings only when a magnet was introduced and only when that magnet was in motion. A moving magnet produces a changing magnetic field within the coil. Remember, transformers are all about changing magnetic fields. Now let's take this one step further. Here we have two coils, each with the same amount of wire. The new coil is connected to the battery pack and is called the primary coil. The second coil connected to the multimeter is the secondary coil. Enter the iron rod. Now you have a transformer, two separate coils of wire that share a common iron core. Since transformers are all about changing magnetic fields, watch what happens to the secondary coil when we break and connect the power source to the primary coil. Break the circuit and connect it. So how are the moving charges in the primary coil able to have an effect on the charges in the secondary coil if the coils don't touch? The two circuits are completely separate. A changing current in the primary coil produces a changing magnetic field. That changing magnetic field penetrates the secondary coil, creating a voltage. The iron rod helps to concentrate the magnetic field lines, allowing the changing magnetic field to enter the secondary coil. This is similar to the effect produced by the magnet moving into the coil, which was shown earlier. Now, what do you think happens when we remove the iron rod? If you break the circuit and then reconnect the power source to the primary coil, break the circuit and reconnect it. The readings are faint, but they're still there. So even without the iron rod, the changing magnetic field is able to travel from the primary coil to the secondary coil. Now back to our cell phone charger. This transformer is built from the same basic parts, two coils around a common iron core. These coils are just a lot closer together. In this case, the changing magnetic field is produced by the AC, or alternating current in the coil, and not by making and breaking contact with the battery. The secondary coil has only 1/10 the number of turns of wire, so the 120 volts AC from the wall is transformed into the 12 volts AC needed for the phone. Do you feel transformed? I sure do. Now go put that toilet paper back on the roll.